So here we're looking at our glossary. So these are the definitions that we should know for our presentation. So we're going to be dealing with science. Okay, science, Middle English, means knowledge, learning. From Old French, Latin, scientia, from science, science, present particle of sire, to know. So science essentially, family, means to know. And that's very key because a lot of people have this misconception of science as if science is some type of abstract type of thing, when science is just knowing something. That's what the root and basis of science means. It means to know. Now, secondly, we're going to be dealing with etiology. This is very key because we're going to be dealing with a lot of origins today. The Eurasians in particular, we're going to be studying the causes or their origins, causes, causation, or causality. Okay, so the cause of their origins or the cause of their emergence from their origins. Okay, so we're going to be dealing with that. Now, thirdly, a lot of you heard this before, haplogroup. So genetic population of a group of people who share a common ancestor on the patrilineal or matrilineal line. So we're going to be dealing with both lines today. No male chauvinism, no pseudo-male patriarchy over here. We're going to be dealing with the divine balance of things, which is the masculine and the feminine, because a lot of people do videos out there and they only want to deal with the male, but they never want to talk about the female, which is very important when it comes to studying population genetics. And last but not least, for our glossary, our definitions, you have phylogenetics. Okay, so in biology, okay, so we have Greek, phyle, phylon, tribe, clan, race, plus geneticos equal origin, source, birth. So again, we're dealing with etiology. We're dealing with origin again. So it's the study of the evolutionary history and relationships among individuals or groups of organisms, e.g. species or populations. These relationships are discovered through phylogenetic inferences, methods that can evaluate, observe heritable traits such as DNA sequences or morphology under a model of evolution of these traits. So this is very important because when you're dealing with phylogenetics, this is what pertains to haplogroups. So that's your group, that's your tribe, that's your clan family. So that is your nation or your quote unquote race. So we're looking at the book African Empires Volume 1, your guide to the historical record of Africa. So around 50,000 BC, the Africans, who were the only beings existing on the planet at that time, began to move out of Africa into Australasia, Arabia, Asia, and Europe. So that's very important because at this particular time, around 50,000 BCE, African people or black people, who some people call Negro people, were the only human beings on planet Earth. There was no pale-skinned people on the planet at this time. There was no white-skinned people on the planet at this time. There was no blue-eyed, blonde hair, red hair people on the planet at this time that was in the class of modern humans. So that's very, very important. So it says, in the present day, we can find examples of peoples in regions outside of Africa who look very similar to Africans. Among the original inhabitants of Australia of present day, we find Aboriginal Australians who still retain features of their African ancestors. Also in Melanesia, which include Papua New Guinea, Fiji, Solomon Islands, and Vanuatu. Again, we find the original inhabitants retaining their features of their African ancestors. That's key because you hear ancestors. The same examples can be found amongst the original inhabitants of the Polynesian Islands. In addition, the indigenous people of Malaysia, called the Semang tribe, the indigenous people of Thailand, called the Manik, and the indigenous people of Philippines, called the Agta, are virtually indistinguishable from native Africans. So that's very important because what he's establishing here is that these particular indigenous people did not mutate as they left out of Africa to the point where they became a different race of people or a totally different people phenotypically. So they still retain their African features from their African ancestors. And we're going to get into those particular people as well because they also play a role in this particular presentation, but they're not going to be the emphasis because they're not the Eurasians we're talking about. Those particular people are also Asians as well, but there's black indigenous people that retain their phenotype and retain, for the most part, their genetic integrity, and there's a reason for that spiritually. So we're looking at a map, the greatest walk. So you see in Africa right there around Ethiopia, you see that point A, and that usually stands for Y chromosomal atom. And you can see he goes through the Bab el Mandeb Strait into Arabia. He goes through the Levant. He goes up into Eurasia, he goes up into Asia, and he continues to walk. So right here we have the greatest human migration began 70,000 years ago in Africa. With a mere eye blink in evolutionary time, our ancestors had reached the last continental corner of the earth, Tierra del Fuego, at the freezing tip of South America. It was a journey of about 22,000 miles. All right, so you can see the walk here. You can look at the map, and the reference for this is the Genographic Project. Okay, so you could go online, go to the Genographic Project, and they could give you some of these different renditions of these different out of Africa migration maps and different things on National Geographics. All right, so this is just another out of Africa migration map. You can see 60 to 70,000 years ago, this migration. This one is a little bit more in depth, a little bit more detail. So you could just look at that. And again, the reference for this is a Genographic Project from National Geographics. So here's Svante Pääbo, who's one of the world's foremost leading geneticists. Svante Pääbo is a Swedish biologist specializing in evolutionary genetics, one of the founder of phylogenetics. He has worked extensively in the Neanderthal genome. Since 1997, he has been the director of the Department of Max Planck Institute for Evolutionary Anthropology in Leipzig, Germany. So we're going to get into a video that he did so you guys can see about the Neanderthal genome. Check it out.
So there's another interesting thing that comes from this realization that humans have a recent common origin in Africa. And that is that when humans emerged around 100,000 years ago or so, they were not alone on the planet. There were other forms of humans around, most famously perhaps Neanderthals, these robust forms of humans compared to the left here with a modern human skeleton on the right, that existed in Western Asia and Europe since several hundred thousands of years. So an interesting question is what happened when we met? What happened to the Neanderthals? And to begin to answer such questions, my research group, since over 25 years now, work on methods to extract DNA from remains of Neanderthals and extinct animals that are tens of thousands of years old. So this involves a lot of technical issues in how you extract the DNA, how you convert it to a form you can sequence. You have to work very carefully to avoid contamination of the experiments with DNA from yourself. And this then, in conjunction with these methods that allow very many DNA molecules to be sequenced very rapidly, allowed us last year to present the first version of the Neanderthal genome, so that any one of you can now look on the internet on the Neanderthal genome, or at least on the 55% of it that we've been able to reconstruct so far. And you can begin to compare it to the genomes of people who live today. And one question that you may then want to ask is, what happened when we met? Did we mix or not? And the way to ask that question is to look at the Neanderthal that comes from Southern Europe and compare it to genomes of people who live today. So we then look to do this at pairs of individuals, starting with two Africans, looking at the two African genomes, finding places where they differ from each other, and in each case ask, what is a Neanderthal like? Does it match one African or the other African? We would expect it to be no difference because Neanderthals were never in Africa. They should be equal, have no reason to be closer to one African than another African. And that's indeed the case. Statistically speaking, there is no difference in how often the Neanderthal matches one African or the other. But this is different if we now look at a European individual and an African. Then, significantly more often, does the Neanderthal match the European rather than the African. The same is true if we look in a Chinese individual versus an African. The Neanderthal will match the Chinese individual more often. This may also be surprising because the Neanderthals were never in China. So the model we've proposed to explain this is that when modern humans came out of Africa sometime after 100,000 years ago, they met Neanderthals. Presumably they did so first in the Middle East, where there were Neanderthals living. If one then mixed with each other there, then those modern humans that became the ancestors of everyone outside Africa carried with them this Neanderthal component in their genome to the rest of the world. So that today then people living outside Africa have about 2.5% of their DNA from Neanderthals. So having now a Neanderthal genome at hand as a reference point and having the technologies to look at ancient remains and extract the DNA, we can begin to apply them elsewhere in the world. And the first place we've done that is in southern Siberia, in the Altai Mountains, at a place called Denisova, a cave site in this mountain here, where archaeologists in 2008 found a tiny little piece of bone. This is a copy of it that they realized came from the last phalanx of a little finger, of a pinky of a human. And it was well enough preserved so we could determine the DNA from this individual, even to a greater extent than for the Neanderthals, actually, and start relating it to the Neanderthal genome and to people today. And we found that this individual shared a common origin for his DNA sequences with Neanderthals around 640,000 years ago. And further back, 800,000 years ago, is there a common origin with present-day humans. So this individual comes from a population that shares an origin with Neanderthals, but far back, and then have a long independent history. We call this group of humans that we then describe for the first time from this tiny, tiny little piece of bone for Denisovans after this place where they were first described. So we can then ask for Denisovans the same things as for the Neanderthals. Did they mix with ancestors of any of the present-day people? If we ask that question and compare the Denisovan genome to people around the world, we surprisingly find no evidence of Denisovan DNA in any people living even close to Siberia today. But we do find it in Papua New Guinea and in other islands in Melanesia and the Pacific. So this presumably means that these Denisovans have been more widespread in the past, since we don't think that the ancestors of Melanesians were ever in Siberia. So from studying these genomes of extinct humans, we're beginning to arrive at a picture of what the world looked like when modern humans started coming out of Africa. In the west, there were Neanderthals. In the east, there were Denisovans, maybe other forms of humans too that we have not yet described. We don't know quite where the border between these people were, but we know that in southern Siberia, there were both Neanderthals and Denisovans, at least at some times in the past. Then modern humans emerged somewhere in Africa, came out of Africa, presumably in the Middle East. They meet Neanderthals, mix with them, continue to spread over the world, and somewhere in Southeast Asia they meet Denisovans, mix with them, and continue on out into the Pacific. And then these earlier forms of humans disappear, but they live on a little bit today in some of us, in that people outside Africa have 2.5% of their DNA from Neanderthals, and people in Melanesia actually have an additional 5% approximately from the Denisovans. Does this then mean that there is, after all, some absolute difference between people outside Africa and inside Africa? In that people outside Africa have this old component in their genome from these extinct forms of humans, whereas Africans do not. Well, I don't think that is the case. Presumably modern humans emerged somewhere in Africa. They spread across Africa also, of course, and there were older, earlier forms of humans there. And since we mixed elsewhere, I'm pretty sure that one day, when we will perhaps have a genome of also these earlier forms in Africa, we will find that they have also mixed with early modern humans in Africa.
Okay, family, so what you just witnessed was the white man and his double talking tactics, like always. You know, we don't expect nothing else from him at this particular time. One minute he says, us Eurasians are all mixed with Neanderthals and the Africans have no Neanderthal DNA. We never found Neanderthal in Africa. No Neanderthal remains in Africa has ever been found. But hopefully one day we want to find that Africans have mixed with earlier forms of humans, which you're never going to find. That's why I put in his Neanderthal dreams, because he's only dreaming. So that's just the white man as usual. But anyways, let's continue on. So right here we have a publication, an article, and it says the genome sequence of a 45,000-year-old modern human from Western Siberia. 45,000-year-old modern human male from Siberia. This individual derived from a population that lived prior to or simultaneously with the separation of the populations in Western and Eastern Eurasia and carries a similar amount of Neanderthal ancestry as present-day Eurasians. However, the genomic segments of Neanderthal ancestry are substantially longer in those observing present-day individuals, indicating that Neanderthal gene flow in the ancestors of this individual occurred 7,000 to 13,000 years before he lived, which is very key, because what this proves is the scientific consensus with regard to the Neanderthal genome, showing that as man left out of Africa circa 50,000 years ago and encountered Neanderthals and admixed with Neanderthals, he actually has more Neanderthal DNA than present-day Eurasians. Okay, so right here we have in the same article, so we're going to read the highlights of the article so we don't have to waste, a lot of time, because we want to go through this really quickly and concisely. So the population to which the Ustashem individual belongs to was more similar to the present-day Eurasians than to the present-day Africans, which likely reflects the out-of-Africa bottleneck shared by non-African populations. The Ustashem mtDNA sequence falls at the root of a large group of related mtDNAs, the haplogroup R. Now keep in mind, because we're going to start bringing up some haplogroups, which occurs today across Eurasia. The Y chromosomal sequence of the Ustashem individual is similarly inferred to be ancestral to a group of related Y chromosome haplogroups K that occurs across Eurasia today. So that's key. So he has the mtDNA haplogroup R and he has the Y chromosome haplogroup K, and we're going to find out later what these haplogroups are. Right, so same article, we're continuing on with our reading. Based on the genotype and data for 87 and 108 non-African individuals, the Ustashem genome shares more alleles with non-Africans than the sub-Saharan Africans. So we're going to go down here. The findings of the Ustashem individual is equally closely related to present-day Asians and to 8,000 to 24,000-year-old individual from Western Eurasia, but not to present-day Europeans. That's key. So he's closely related to more individuals in present-day Asia and not present-day West Eurasia, which is the European group. So here we're looking at a map of the Ustashem individual that they found 45,000 years ago. All the way up there, you see the blue arrow pointing to the little green dot. Ustashem site in northern Eurasia. This is in central Siberia. You can see it's far north as man migrated out of Africa. Man and woman migrated out of Africa. They were drawn up into different parts of northern Eurasia. Again, he carried haplogroup mtDNA R, which is mitochondrial DNA haplogroup R, which is the female, and he also carried Y chromosome K. And we're highlighting these haplogroups, so keep in mind these haplogroups, take notes or go back over the presentation. I apologize, we have to go through this. I promise it's all going to make sense at the end. We have to put these haplogroups together because I'm going somewhere with these haplogroups now. So bear with me and just stay tight and continue on with the presentation. Now we're following that up with another article. So, an early modern human from Romania with a recent Neanderthal ancestor. Neanderthals are thought to have dispersed in Europe 39,000 to 41,000 years ago, but they have contributed 1 to 3% of DNA of present-day people in Eurasia. Here we analyze DNA from a 37,000 to 42,000-year-old modern human from Oasi, Romania. So we find that on the order of 6 to 9% of the genome of the Oasi individual is derived from Neanderthals. Let me read that again. We find that on the order of 6 to 9% of the genome of the Oasi individual is derived from Neanderthals. 6 to 9%, family. Take notes. Keep this in mind. More than any other modern human sequence to date. 3 chromosomal segments of Neanderthal ancestry are over 50 centimorgans in size, indicating that this individual had a Neanderthal ancestor recently as far as six generations back. So you see this individual has 6 to 9% Neanderthal. This is the highest that we found so far. This has been the highest to date that has ever been found of Neanderthal ancestry. And this individual dates back 39 to 41,000 years ago. So he actually has more ancestors that belong to Neanderthals, or more genetic ancestry that belong to Neanderthals, than the Ostersem individual that we was just dealing with that go back to 45,000 years ago. So this is very key. Again, we see a Neanderthal DNA coming up, and we see it also haplogroups coming up. So we're highlighting Neanderthal DNA in relation to the haplogroups signatures. Continuing on with the same article. The mtDNA sequence based on deanimated fragments is related to a large group of present-day Eurasian mtDNAs, haplogroup N. This OAC1 mtDNA carries a few private mutations based on which its age can be estimated to 36,330 years before present. Then we go down here. Now we're going to go down. And it says the Y chromosome alleles belong to the haplogroup F, which is carried by most males in Eurasia today. This is very key. I'm going to highlight this. The Y chromosome alleles belong to the haplogroup F, which is carried by most males in Eurasia today. This is very key. And his mtDNA haplogroup, again, his mitochondrial DNA haplogroup, which is the female side of the spectrum, the X chromosome being passed down, okay, to the male. The woman also passed down her mitochondrial haplogroup to her daughters as well. However, the man only passed down his Y chromosome to other males. So the mother passed down both sex chromosomes to the man and the woman, whereas the man only passed down his Y chromosomes to his sons. So here we're looking at a reconstructed clay sculpture from bone fragments via cave pastora Q Oase. So this is the individual that we're talking about in the article. This is how he looks. I know a lot of people saw him floating around on the internet, or they see him floating around on the internet. He's been out here for a while now. So he's actually who we're talking about in this particular article. So he's dated 37 to 42,000 years ago. Again, his mitochondrial DNA is N, and his Y chromosomal DNA is F. All right, so that F haplogroup that belongs to the Y chromosome is very key, because this marker we're going to highlight in a little while, and we're going to show you what it actually means and what it represents for the Eurasian races, or the Eurasian males in specific. Also that N as well. So he carried two haplogroups that a lot of modern day Eurasians actually still carry, specifically the mtDNA mitochondrial N. A lot of Eurasian women carry that marker today, especially Western Europeans. So this is how our ancestors were looking as they migrated out of Europe into Eurasia and settled there, or was wandering around as hunter-gatherers at this time. We're looking at the Khoisan type that still resides in South Africa today. Okay, they're most likely, for the most part, a hunter-gatherer type of people. They speak a click language, as you can see. This is very reflective of the individual that was found in Romania. There you go. This looks like his descendants today. Before he mutated and became the modern day Eurasians, or before he became a part of the amalgamation of the people who gave rise to the modern day Caucasoid, Pale Arab, Western Europeans, and South or Northern Turks, and so forth and so on. So this particular individual, you can see his descendants, beautiful people, beautiful African people. There might be some, Bantu element in there as well, but this is clearly Khoisan, Khoi admixture, and here they are today. They got kinky hair, they got wide noses, and so forth and so on. Humans and Neanderthals likely interbred in the Middle East. Humans and Neanderthals likely interbred in the Middle East. Not Europe. Humans and Neanderthals likely interbred in China. No. Humans and Neanderthals likely interbred in Australia. No. Humans and Neanderthals likely interbred in the Middle East. This is the name of the article. We're going to get into the Neanderthal genome a little bit more. Remember, the Oasi, Pestera Q Oasi individual, the Khoisan looking brother or ancestor from 40,000 years ago, he had 6 to 9% Neanderthal DNA. That's the highest that has ever been found. So we're going to get into a little bit more specificity with regard to this Neanderthal genome. Our ancestors likely had sex with Neanderthals. Our ancestors likely had sex with Neanderthals. Whose ancestor? Okay. The discovery of a 55,000-year-old partial skull of modern human in an Israeli cave, the first sighting of Homo sapiens in this time and place, offers skeletal evidence to support the idea that Neanderthals and modern humans made it in the Middle East between 50,000 and 60,000 years ago. Now we're going down. 2 years later, scientists compared ancient DNA extracted from Neanderthal fossils to that of contemporary modern human populations around the world, concluding that this interbreeding took place in the Middle East, most likely between 47,000 and 65,000 years ago. And last year, a 45,000-year-old modern human found in Siberia, which we talked about earlier, the Ushtasem individual in central Siberia, northern Eurasia, the oldest modern to have its genome sequenced, was revealed to have harbored a little more than 2% Neanderthal DNA. That's key. So he had a little bit more than 2% Neanderthal DNA, allowing research to refine the interbreeding event to roughly 50,000 to 60,000 years ago. So, seemingly, the first admixture with Neanderthals took place in modern-day Palestine. Ain't that some You know, it's just so interesting how this Holy Land has all these peculiarities that are just a mystery, all right? But we're going to get further into some of these, mysteries and so forth, so to speak. Manat is the first and only modern human securely dated to 50 to 60,000 years ago outside the African continent. Hershkovich says that means that the Middle East was the most likely place for the love affair between modern humans and Neanderthals. Ooh, this European man, these Caucasoid man, these Eurasians, they love their past. That's one thing with the Eurasians, man. They celebrate their ancestors, man. Even if they was, dibbling and dabbling in some stuff they wasn't supposed to. So, continuing on, this is something we did not have fossil evidence for earlier. Chris Stringer, a paleoanthropologist at the Natural History Museum in London, asked that the partial skull clearly represent a modern human and closely resembles the skulls of European Cro-Magnons, which we're going to talk about later, the modern humans who took over Western Europe from the Neanderthals and possibly helped drive them extinct by 35,000 years ago. Good old goddamn. And the story only gets better. Rich sexual past between modern humans and Neanderthals revealed by Ann Gibbons. The other article was by Michael Balter. This one is by Ann Gibbons, and this is an official website, sciencemag.org. Modern humans, Neanderthals, and a second kind of archaic human called Denisovans met and mated. The researchers conclude that if you're an East Asian, you have 3 Neanderthals in your family tree. Europeans and South Asians have 2, and Melanesians only 1. Africans whose ancestors did not mate with Neanderthals have none. Add in 2 additional Laotians, known only from fossil DNA, and the ancestors of modern humans and Neanderthals mix it up at least 5 times. Jeez, that's disgusting. You see what I'm talking about, family? They got some nerves to be putting these articles on these websites and giving it titles like this. They just might as well name it the Neanderthal origin. And what were their ancestors doing with these Neanderthals? So let's just read the rest of it. When researchers spotted the traces of Neanderthal nuclear DNA in living people, they assumed that it must have come from a rare maiden or 2, likely when modern humans left Africa and first pushed Neanderthal territory in Western Asia. But since then, the family history of modern humans and their cousins has grown tangled. Not us black indigenous African people. We do not have nothing to do with that Neanderthal. And you're going to see that. And the reason why I'm bringing up the haplogroups and the Neanderthal admixtures is because I'm going to show beyond a shadow of a doubt, unequivocally, that the people that gave rise to the modern Caucasoids or so-called modern Europeans, modern pale Arabs, modern Jews, modern pale Chinese, modern East Indians, all these straight-haired people, all these curly hair people, even with dark skin, we were not the ones that they came from. So we have a map, another map. We like visuals, so we're going to give you visuals. So here you see the Neanderthal remains all over Western Eurasia. Right there you see in southern Canaan. Right there in Palestine, they found Neanderthal bones and man. They've also found it in northern Canaan. They found it in Western Europe. They found it all throughout Asia Minor. They found it all throughout the Fertile Crescent. Okay, and then you have the green highlight, which is the Denisovan. Okay, and so this is where the Southeast Asians and Oceanic populations, the Australian Aborigines, the Melanesians, Polynesians, Fiji Islanders, and so forth. This is who they admix with. Now, we're not going to deal with these particular groups entirely in this presentation because they're not problematic to us in light of our actual African origins of the ancient Israelite presentation. We're going to deal with the Western Eurasians because we have to identify who they are as it relates to us so that we can firmly understand where we were, what we were doing, and who were the people that we were at odds with, who we were in conflict with for thousands and thousands and thousands of years. It has always been the same people. Looking at another map, the human strain. Here again, we see the out of Africa migration. You see the Neanderthals right there in the highlight, interbreeding in the Far East, Denisovan in the red, the Denisovan cave in Siberia, and the Neanderthals. Look where the Neanderthals were located, family. This is from National Geographic. This is from the Genographic Project. All of my references, all of these publications and articles are all legitimately classified sources. All right? These are all legitimately proven scientific sources. This is not no little, website online where somebody's writing a little article. These are all peer-reviewed articles that we went to the primary source to get. We're just showing you some reference points to these particular articles right now. And as you can see, there's dates here, there's a chronology, so I'm actually following a timeline. If you notice that we're still around 50 to 40,000 years ago, we're still around this particular period. So what I did was I said, you know what, I'm going to take us from all the way back around 60 to 70,000 years ago, all the way up until the last glacial maximum, going into the Ice Age and going into the post-glacial period, and showing you who these people were in the past and who they became in the future and who they are today. Paleolithic settlement, earliest developments. The period of human activity in the end of the last major Pleistocene glaciation, about 8,300 BCE, is termed the Paleolithic period or Stone Age. That part of it from 35,000 to 8,300 BCE is termed the Upper Paleolithic. 750,000 years ago, there have been 8 major cycles. Some parts of southern Europe may have been little affected by these changes, but the advance and retreat of the ice sheets and the occupying glacial environments had a significant impact on northern Europe at their maximum advance. They covered most of Scandinavia, the North European plain, and Russia. So this is where some of these people that left out of Africa got caught up at. They got caught up in some cataclysmic events that took place during the last glacial maximum, which is quote unquote, the Ice Age. So these particular people, not only did they mix with Neanderthals and so forth in Western Eurasia, in Asia Minor, in Northern Europe, in Siberia, etc., 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 they also suffered this particular tragedy that came later on as a result of what they were doing and where they were at. We don't believe in nothing coincidental as African people. We know everything happens for a reason. The subsistence economy depended on hunting and gathering. The main evidence is animal bones, which suggests a varied reliance on species such as rhinoceros, red deer, ibex, and horse, but it is difficult to reconstruct how such food was actually acquired. Now let's go down. Rhinoceroses and mammoths were driven over a cliff edge. Scavenging meat from already dead animals also may have been important. Food sources such as the migratory herds and plants were available only seasonally. So annual strategy for survival was necessary. It is not clear, however, how it was possible to store food acquired at times of plenty. Carcasses of dead and animals frozen in the snow would have provided store of food. So again, family, this is the Upper Paleolithic, and this is how they were living as hunter-gatherers. It was not the most easiest time. It was very difficult for these Eurasians at this time. Forensic Kostenki 14 bust, Markina Gora, 36,000 years ago. So again, family, we're still in the Upper Paleolithic, which is the Stone Age. So we're showing how these groups of people who left out of Africa, of course, black African people, they're clearly still black and Africoid at this particular time. But look and see, you're going to start to see the varying changes that started to occur in the Upper Paleolithic and going into the end of the Stone Age. So second oldest modern human genome that has been sequenced. Y haplogroup is C and maternal haplogroup is U. So we're back to the haplogroups again. Y haplogroup C, maternal haplogroup U. So it says, here we have a quote from sciencemag.org. From the sequence data, they found gene variants indicating that the man had dark skin and eyes. He also had about 1% more Neanderthal DNA than do Europeans and Asians today, confirming what another, even older human from Siberia, the one we discussed first earlier in our presentation. Siberia has shown that humans and Neanderthals mixed early, before 45,000 years ago, perhaps in the Middle East. The man from Kostenki shared close ancestry with with hunter-gatherers in Europe, as well as with the early farmers, suggesting that his ancestors interbred with members of the same Middle Eastern populations who later turned into farmers and came to Europe themselves. Very, very important. So again, as you can see, this is an Africoid individual, but look and see, you start to see morphological changes. Look at the hair texture. His hair texture starts to become more loose, and his hair is getting more wavy. Instead of kinky and coily, it's getting straight, as you can see. And again, he carried Y haplogroup C and maternal haplogroup U. This is where things get really interesting. Paleolithic DNA from Eurasia. So what I did was I said, you know what? In order to sum up this presentation, I'm not going to go through all of the different archaeological finds and go through all their haplogroups. I found a beautiful website that actually lays out all of the archeogenetic finds that they found through the course of time. Okay, so it's recent, it's updated, and you can go to this website and you can get all the actual haplogroups. You can get the culture, the country they were found, the sites they were found, the date, the sex, the Y-DNA haplogroup again, and also the mtDNA haplogroup. Some of them don't have haplogroup because the statistical methods that they use could not ascertain the haplogroup. So some of them is void of a haplogroup, but nevertheless, we're looking at right here, Paleolithic DNA from Eurasia. And so where we see in row 1, we see Russia, the country, right? And Ushtasin man, which we talked about earlier, Western Siberia, he was a male, 47,000 to 42,000 years ago, before present, and he carried Y-DNA haplogroup K and mtDNA haplogroup R. The Romania man that we talked about earlier, Pestera Q Oase, okay, 37,000 to 41,000 years ago, he carried Y-DNA F and mtDNA N. The culture, the next one is Proto-Argonatian culture. Countries in Italy. They found another individual, Grati di Fername or Fermain, that's from 41,000 to 38,000 BP. He carried mtDNA R, or she carried mtDNA R. There's no gender there. Okay. So, okay, Russia. So you have Kostenki Markina, which we just talked about. So what we're looking at again, Argonatian culture, Belgium. Okay, 35,000 to 34,000 BPE. You can see this individual is a male. He carries haplogroup C1a, mitochondrial haplogroup M. The Gravettian, Italy, Grata Plagici, male again, 34,000 to 31,000 years ago. This particular individual carried haplogroup I, mitochondrial haplogroup U8C, so haplogroup U. Argonatian culture again in Belgium. This particular individual was found 33,000 years ago. No male haplogroup, no sex. They couldn't identify the sex again, but the mitochondrial haplogroup was M. So they could identify the mitochondrial haplogroup. So we have M, U, and M for the mitochondrial haplogroup on this one, and we have C1a, which is haplogroup C, and haplogroup I. Then we go down to Romania, Pistera again, and then Romania again. We find a female, and she is 32,000 to 33,000 years ago, and she carried haplogroup U6. All right, so now we go to Russia, Kostenki, Volkovachkaya. And so this particular male, also 31,000 to 32,000 BP, 32,000 around 32,000 years ago, carried haplogroup CT and mitochondrial DNA haplogroup UT. So he carried, the paternal lineage was haplogroup CT and the maternal line was haplogroup UT. Now, what's very, very important about what we're bearing witness to right here is that none of these particular individuals so far that has been sequenced or genotype archeogenetically shares any haplogroup that modern day African people carried. So not only did the Africans that left Africa admix with Neanderthal DNA that modern indigenous Africans don't carry to this very day, only through recent contact with Eurasians, they also don't carry none of these out of Africa migratory haplogroups. That's very important. If you notice, for those of you that's up to par with your genetic studies, you'll notice that there's no haplogroup E1B1A and there's no haplogroup E at all, no B or A that has been found. You know, of course, you're going to find small fragments of BT because that's also considered an out of Africa migratory haplogroup. However, the indigenous B, A, and E haplogroups that's indigenous to Africa has not been found in the Upper Paleolithic that precedes the last glacial maximum to the post-glacial period in the Ice Age. This is very, very key, family. Continuing on, now again, here we have a Wikipedia source. And now for those of you out there who say, oh, he's using a Wikipedia slide, there's nothing at all wrong with Wikipedia. It's just that Wikipedia is more surface information. If you just read through Wikipedia, you'll see that on the bottom, Wikipedia does provide references. So, you know, there's nothing wrong with Wikipedia. It's just that a lot of people, they'll read a Wikipedia article and they'll take that at face value and then start propagating that information like it's 100% accurate, as if they circumvented all the sources themselves. They have not investigated the primary materials. So nothing wrong with Wikipedia. So we provide Wikipedia as a quick reference so we don't waste no time. So this is a quick reference so you could just go up and look this up. All right. So here we have, again, haplogroup F M89. So we're dealing with haplogroup F, which the Kostenki individual carried. We talked about that earlier. So now we're going to get into what haplogroup F actually means and who are the descendants of this haplogroup today. Haplogroup F, also known as FM89 and previously as haplogroup FT, is a very common Y chromosome haplogroup. The clade and its subclades constitute over 90% of paternal lineages outside of Africa. Let me read that again. The clade and its subclades, meaning the subbranches that descend from haplogroup F, the varying slight mutations of haplogroup F, over 90% of the paternal lineages outside of Africa belongs to this haplogroup, okay? The vast majority of individual males with FM89 falls into its direct descendant haplogroup GHIJK. Now that's very important. We're going to go through that also. These three with F constitute the paragroup FGHIJK. Okay? So we're going to go down in the highlight. HIJK in turn splits into H, and IJK, the descendants of haplogroup IJK include haplogroups IJK and ultimately several major haplogroups descended from haplogroup K, namely haplogroups M, N, O, P, Q, R, S, L, and T. So now you can see clearly that I wasn't playing, I wasn't joking, I wasn't lying about the article we just was looking at, because you can see some of the reflective haplogroups of that article right here. You see K, you see these different haplogroups. So these are the haplogroups that the Eurasian groups today carry because they descend from haplogroup F. Haplogroup F is the macro haplogroup that gave rise to all of the submutations that the modern day Eurasians carry, whether you're living in the Middle East in Saudi Arabia, whether you're living in Western Europe, whether you're living in Siberia today, or Russia, or you're living in Palestine, they all descend from this particular ancestor. All right? Now, following that up, now we're looking at the actual map of this particular haplogroup F that came out of Africa, and you can see all its variant sub-branches right there. You can see that's around Western India. Okay, so you see the dispersion of all these descendants: Q, R, L, I, J, G, J, I, R1b, R1a, P, K, NO, O, N, M, and S. All of these groups today descend from haplogroup F. This is an out of Africa haplogroup. Again, no indigenous people in Africa carry this marker because they always remained in Africa, and we are also the descendants of those that remained in Africa. So for all the fools out there, the Negroes out there, the self-haters out there who keeps talking about we come from Turkey, we come from Mesopotamia, we come from Canaan, we come from this, we come from that, we come from Mars, we come from space, we come from Lemuria, we come from Atlantis. Your ass is an Afurakan all the way, every day, until you can prove that you descend from these people and you have Neanderthal DNA and you have recessive features, straight hair, wavy hair, pale skin, blue eyes, blonde hair, and all these different mutations that comes with these SNPs that give you specific genetic traits that give rise to different diseases and so forth. You are nothing but an imposter, fool that's perpetuated white supremacy against your own people. All right? And forgive me, brothers and sisters, I really apologize. This thing just get me really hyped up and get me really infuriated sometimes when I talk about this, because got a lot of these Negroes out there, these anti-self-haters out there, these self-haters out there that continues to perpetuate this anti-African doctrine. Their disposition, from their sayings to their slogans, they all hate themselves. And you know what? It's not wholeheartedly their fault. It's not wholly their fault, because a lot of us had suffered a great deal of self-hatred at some point in our lives, but some of us fortunately were able to overcome it. But there's just a whole host of people still suffering from self-hatred. And as a holistic health advisor, one that deals with ascertaining the underlying culprit of diseases, I have diagnosed the black community in general, and we're people that's suffering from self-hatred. And in order to overcome self-hatred, in order to transcend self-hatred, we need a holistic approach in our recovery. And that's the only solution to black liberation, a holistic, multi-dimensional approach. But let's continue on with the presentation, brothers and sisters. So right now we're looking at, again, another more graphic chart, the out of Africa migration. So you can see CT, CF giving rise to F right here in northern Western India around Eurasia again. Okay, in the quote-unquote Middle East, giving rise to K, K branching off into N and O, into Southeast Asia and so forth. So a lot of the East Asian groups carry those particular branches. Those are the indigenous people that admix with the Denisovan. And then you have the P that give rise to the R and the IJ. We're going to talk about those particular two haplogroups too, because they're very important to the destruction of black African civilization. And so we had some of them back migrated into Africa as well. Seeing the wood for the trees, a minimal reference phylogeny for the human Y chromosome. Okay, so this is another article. See the source, academia.edu or edu. And this is just an article, a publication that goes into detail on the phylogenetic tree. They have a very broad phylogenetic database. So this is the one that we deal with because this one is up to date and is very, very extensive. So we're continuing with the script. So we're looking at the phylogenetic tree, an extensive version of that outside of Africa. So you can see all of the regional geographic areas where these haplogroups are predominant in today. You see CF, which gave rise to C, and F, and from F, it gave rise to GHIJKLT. And you can see right there on the right, all of the areas, all of the countries and so forth, where these haplogroups are prevalent in. They frequent at its highest in these particular regions today. And you can see the lineage as well and how these particular groups mutated and branched off into their own unique subclades. And so you could just go into the website, phylotree.org, again, family, and you can, research this or, investigate this further. We don't want people to just take things at face value. We encourage everybody to do their own due diligence. We encourage everybody to do their own inquisitions into the stuff that we've produced because, it's enough of this whole, man worship or this personality worship type of mentality that black people tend to have. And we really just learned it from slavery.